let us begin. Metal forming. What is metal forming? Sana sana, when we talk about metal forming, we are talking about the deformation of these metals using certain processes. Sana sana, when we talk about the deformation, we mean plastic deformation. And plastic deformation is the permanent deformation of a material or a metal in this case. When I bend a metal and I change its internal structure, when I bend a metal and it deforms permanently, that is what I call metal forming. And depending on the type of process, the type of procedure that I'm going to take, I can use different tools. I can use different processes. I can use different machines. Mfano ni hizi ambazo hapa tumesema ni die. Kuna die, kuna punch, and we will see these tools in the next topic ambayo ni workshop tools and processes. But in hindsight, metal forming is a process in which we deform metals permanently, and that permanent deformation is what we call plastic deformation. I do not know if you can see my diagram clearly. I'm at this table. If not, let me know so that I can maximize it. Anyone, can you see this diagram? You can unmute and tell me if you can see it. Okay. Okay. Now, these processes are usually categorized into two broad categories. The first one is bulk deformation, and the second one is sheet metal working. When we talk about bulk deformation, tunamaanisha kwamba we are dealing with large forces. We are dealing with large forces, large work pieces, large metals. When we talk about sheet metal working, tunamaanisha kufanya kazi na metals that resemble mabati. Under bulk deformation, under processes that require large forces, we have rolling processes, we have forging, we have extrusion, we have wire drawing, and under sheet metal working, we have bending, we have cap drawing, we have shearing. We will look at some of these forces individually. We have so that you can have an understanding of what these forces are. What these processes are. Tutaziangalia tu in briefly and explain what they are. Now, under bulk forming, let us start with the rolling process. And the most common example ambayo I can give is kuna ule mtu ambaye anatengeneza juice ya miwa. I think we have seen him around. Ile machine ambayo anatumia is a rolling machine. That rolling machine usually is used to compress the sugar cane, ili utoe ile juice. It will pull the sugar cane inside those rotating rollers, and then compress that sugar cane ili upate ile juice. And it is the same in a workshop ama in an industry. If I want to compress my metal ili itoke kama mabati, the end product is a sheet like metal. I will use a roller, a rolling press. So it will draw or it will pull that metal into those rollers, those rotating rollers, and the final product I get is a sheet like metal. I will just play a simple video so that we can have a visual understanding of what the rolling process looks like. So if let me know if you can be able to see it and if you can be able to hear. And I'm going to ask again, Mara Musha, please, if you're not asking a question, let us mute our microphones. Let me play a video and then let me know if you can be able to see it. I think we have Ahmed, tafadhali mute your microphone. Now, I think we have seen the process itself. Niko sure sasa we have an idea of how rolling takes place. We have a piece of metal being pulled into those rollers. Once it is pulled into those rollers, it is compressed. Then what comes out on the other side is a compressed sheet of metal. Now, another process that is common under bulk deformation is forging. Forging is the process ambayo I think we've seen it pia katika blacksmiths. A blacksmith will take a piece of metal, he will heat it, he will deform it under forces. This is the process of forging. There are very many types of forging, but the idea itself is that you take a piece of metal, you compress it in between dies. Dies are this in this diagram isn't your die. Sana you find that if, let's say for example, I have a die that ambayo iko na shape ya msalaba, and I place my piece of metal inside those dies. Once I compress that metal, my piece of metal will take up that shape. So basically the idea of compression of forging is you compress, you apply force, be it by heating, be it by machine, you apply force on a workpiece continuously. And that is what we call forging. Now we have another process known as extrusion. We have another process known as extrusion. Extrusion is a process in which you have a die. Ahmed, please. Thank you. Now we have a process ambayo inaitwa extrusion. You have a piece of die hapa. We have a workpiece. We push that workpiece through this die, this cross-sectional area die. And that process is known as extrusion. Sana we do this if we want to change the shape of our workpiece. If I have a cylindrical metal and I want to change it to rectangular, or square, or triangular, I will just take a die whose cross-sectional area is triangular, so that when I push that circular workpiece through that cross-sectional area, it will take that shape. I might assume that shape. Now this piece of metal is pushed by something known as a ram. We will see that shortly in a video, but inasukumwa na kitu ambayo inaitwa a ram. The workpiece is usually known as a billet. A billet, B-I-L-L-E-T, but you can still say it is metal or a workpiece. We push that by applying a force through a die, and the final product is usually dependent. Itategemea the cross section. If I have 3 holes, then 3 pieces of metal will come out. So let us look at a video and see how this is usually done in the workshop or in the industry. I'll stop the video at that point, but I think we have seen how it is usually done katika workshop or in the industry. We push that metal through hydraulic means, or maybe any other means, and we push it in a die, and it will assume the shape of that die. the cross-sectional shape. If the purpose of extrusion is to reduce the area, we will push it through a die whose area is less than that of the die. If the purpose of that is to change the shape, we can be able to change the shape of that material. Sawa sawa. If you're together, please unmute and say that I am present. Nisikuwa naongea peke yangu. Thank you very much. Thank you. Now, let us look at another process known as wire or rod drawing. It is a very similar process to extrusion. The only difference is we are not applying a force. We are not pushing the workpiece or the billet into the die. We are pulling it. Are we together? Tunaivuta. We pull it using a certain force at a certain velocity, and that workpiece will pass through that die, and it will reduce the shape or it will change the shape. It is similar but not the same. In extrusion, we push. In rod drawing or wire drawing, we pull. The term drawing itself is pulling. Sawa sawa. Are we together? Now those processes are some of those that we can find under bulk deformation. When we go into sheet metal working, we have processes kama bending. Bending, as the name implies, ni kukunja. You take a piece of metal, ama a workpiece, we place it on top of a die. That die has an opening of a certain angle. It might be 20, it might be 60. Kutegemea how much we want to bend it. We apply a force on that metal using a punch or using a ram or a die. We apply a force. That workpiece will enter into that hole and assume that angle. Oh, I am very sorry. I'm sorry I'm going too fast. What I'll do is I will send this material to the Google Classroom so that you can get it there. I know I cannot send it through WhatsApp kwa sababu ni kubwa sana since it contains videos. So in case I go too fast, let me know. I'm sorry so much, Bernard. Thank you for letting me know. Now, as I was saying, that we will apply a force through that workpiece. Kisha itakunjika. The most important parts in the bending is the contact points. This point at this upper, at this point, and at this point. Are we together? The opening of this die, if it is a large opening, then I will use less force to kunja that metal, to bend it, as compared to kama hiyo shimo ilikuwa ndogo. What do I mean? If I have a deeper, we will see that shortly in a short video. If this hole is ni kubwa to that extent, I will use more force as compared to less force as compared to if that opening was little. Now let us see how bending operation is usually done in a workshop or in the industry. Now, I think we have seen the idea of how bending is done. We have a die ama a press ambayo inasukuma the workpiece into those openings. Now, the shape of the corner will be dependent on this. The shape of the corner ama of that bend will be dependent on this punch. So if I want to have a circular corner, I will just use a circular punch or a circular die. If I want to have such a square corner, I will use such type of a die that has such an edge. I think tumeelewana hapo. Now, another process that is under sheet metal working is dip or cup drawing. This is this process. Let me show a diagram so that I can explain. This process is usually, we take a piece of sheet metal, tunaiekelea juu ya a die that has a hollow or a concave shape. We take a piece of these blank holders. We make sure that we have attached, we have secured that sheet metal tightly, and then we will apply a force using a punch. We will apply a force using a punch, and we will push that workpiece into that cavity. And what happens is that metal is usually stretched in certain parts. Hiyo chuma itakuwa itavutwa katika certain parts, and then it will assume, or it will take that shape of that die. Sana we do this when we are forming things like bottles or cups, metallic bottles. That is a process. Are we together? We take a sheet metal, we attach it or we hold it tightly using clamps. Those clamps are known as blank holders, and then we push or we apply a force using a blank or a die, using a die or a punch, and we push that sheet metal into that cavity. And the metal will assume that shape, or it will take the shape of that cavity. This process is known as deep drawing or cup drawing. Sawa sawa? Tuko sawa? Tuko pamoja? Kabisa. Now let us play a small video so that we can see ideally how this is usually done katika industry. Now what I want you to see is this part. We have flat sheet metal, ambazo ziko flat, and they are being pushed into holes, concave holes, and that metal assumes that shape. Now, I think we have seen how it is usually done, unless there is a question. Kuna swali? Ama mnataka kuona video tena? Is there a question? Kuna swali, let us continue then. Now, shearing. Shearing ni essentially kukata. The most common example I can give is using scissors. The process of cutting when you're using scissors is shearing. We can do the same using metal, but now hatutakata chuma na makasi. No. What we do is we apply, we put our sheet metal on top of a die, and then we apply a force using a punch. Hiyo chuma itakatika using shearing force. Are we together? This is the most, it is a very simple explanation. You are cutting a piece of sheet metal using shearing force. And that force is usually gotten by applying a force using a die. Utakuwa umekelea your piece of metal on top of a die, kisha unaikata. Sawa sawa? Are we together? Okay. Now these processes, ambazo we've mentioned, there are so many workshop processes, metal forming processes, but these processes are usually categorized into two major processes. Yeah, it can be cold working or hot working. Now, when I say cold working, is that I'm working on those metals under something known as recrystallization temperature. Now, let me explain what recrystallization temperature is. When you hit a piece of metal, just before it melts, before you hit the melting point, new crystals are usually formed. New particles, new atoms will be formed within that metal. Now, when we do these processes below that temperature, we have not heated that metal. Let's say if I work on a piece of metal, if I'm forging at room temperature, then I'm working on that metal under below the recrystallization temperature. That process is cold working. That's why I was saying that there are many types of mfano forging. I can hot forge, I can cold forge. Sawa. Now, cold working has advantages. And the biggest advantage is you can achieve close tolerances. What do I mean? Accuracy, ile workpiece ambayo the accuracy of your workpiece will be higher. Why? If I'm going to be forging, if let's say I'm going to be rolling a piece of metal under room temperature, my accuracy, if I say I want to machine that, I want to have a final product that is 18 centimeters by 18 centimeters, I will have a tolerance of maybe plus or minus 1 centimeters. Yeah? It will be better. It will my dimensions will be more accurate as compared to if I heat it. When I heat a piece of metal, then I work on it, then I have to take into consideration the expansion and the contraction of that metal. But during cold working, the dimensions are the accuracy is better. The surface is better. Reason is, when let's say I am rolling my piece of metal, there is nothing else I'm doing on that surface. Ni kukunja tu, ama I'm compressing or I'm forging. So the surface, my surface will be better as compared to, let's say if I heat that piece of metal before I work on it. Why? Because if I heat that metal, I am exposing it to the elements. It will rust faster, it will decay faster, there will be formation of scales, oxidation will happen. So the surface finish of a cold worked metal is better. Now, since I'm not going to be thinking of heating that piece of metal, then the cost of my fuel and the electricity, itakuwa chache. Bill ya KPLC will be lower as compared to that person ambaye anatumia stima, anatumia mafuta kuheat his metal. Machining requirements, I won't have to go back to after I'm done with whatever I'm doing. Let's say I'm forging a piece of chair, a metallic chair. I won't, the machining requirements, the cutting, the filing, the polishing will be less as compared to that person who has to heat his metal. And those are some of the advantages of cold working. Now, disadvantage ni zipi? Strain hardening, mfano forging. If I heat a metal continuously under the recrystallization temperature, the internal structure itakuwa ngumu. It will get to a point that I will have to apply so much force so that I can get that metal deformed. Are we together? And for that reason, higher forces, I will require higher force just to deform the same a piece of metal. As compared to that person who has to heat that metal first. I will have to require higher forces. Itabidi nitumie nguvu nyingi. If I'm going to be using higher forces, then my equipment, my equipment will be high, will be more powerful, will be larger, will be bigger. Sawa. Now, some work pieces, some metals cannot be worked on under those temperatures. You have to heat them. Kuna chuma hata ujaribu kukunja namna gani haitakunjika. We had talked about ductility, the properties of materials. I will refer you back to those properties. If you don't remember, please let us revise so that tusisahau sana. So some pieces cannot be deformed under tensile or compressive stresses. So they have to be heated. Now, the opposite of cold working is hot working. We have to heat that metal above the recrystallization temperature so that we can work on it. I've said recrystallization temperature is the temperature at which once you hit a metal, new crystals, new grains, new structures are formed within that metal or that material. So when we work on a metal above that temperature, not the melting point, mind you, that metal has not melted. It is not, that process is hot working. So all those processes we had mentioned before, I can either cold work or I can hot work. Now the advantages of hot working is I use less forces. Wale watu ambao wanafanya kazi ya blacksmith, they heat their pieces of metal before they heat it. Because it will be easier to deform that metal, I will require less force to deform that metal. There's no limit of hot working. What do I mean? If I'm working on a piece of metal, if I'm forging a chair, mfano, and I'm not satisfied by the shape, by the dimensions, I can reheat that piece of metal over and over again. I can heat it, work on it. Niongeze temperature, I work on it. As many times as I want, until I am satisfied. So there is no limit to the amount of hot working that can be done. Now, since you are forming new grains all the time, since you are working above that temperature, the recrystallization temperature, then the structure within that metal is better, is finer, as compared to cold working. If I have cracked, or if I have impurities, if I have kama nina shida in my metal, in cold working, those problems will still remain. But in hot working, since I'm continuously forming new crystals, then my crystal structure, my grain structure within my metal is finer. Concentrated impurities, if I have problems, if I have impurities within my metal, once I hit that metal, they are broken down, zinakuwa redistributed. Then that means that I'm reducing the weakness. I'm reducing the weakness of that metal by redistributing the impurities within that material, within that metal. Now let us look at some disadvantages. Since I'm heating that metal will be exposed to the elements, and it will be reactive. It will react with the elements, the weather, the environment faster than a cold worked metal. We'll have formation of scales, we'll have formation of rust, we'll have formation of impurities on the surface. And for that reason, we have a very poor surface. So that means you'll have to, after you're done working on your metal, you'll have to clean it, you'll have to polish it, you'll have to machine it. Some metals, increase temperature, it cracks, it breaks easily. So you have to be very careful that you don't work. There are some metals that you cannot be hot worked. That's the same way that we had metals that cannot be cold worked because they're not ductile enough. They cannot be bent easily. They cannot be deformed under tensile compressive stresses. The same is applicable in hot working. When you hit some metals, they break. Zinakuwa kama glass. When you talk about accuracy in hot working, you have to consider that when you hit a metal, it will expand, it will contract. So you have to be very considerate when you're talking about accuracy. Because if I'm going to be making a piece of metal of 10 centimeters by 10 centimeters, once I hit it, it will expand, let's say, to 15. Once it contracts, labda itafika 9. So when you talk about accuracy, then it is difficult to achieve because you have to take into consideration the expansion and the contraction of that piece of metal. If you are together till that point, say I'm present. Tuko sawa mpaka hapo. Thank you very much. Now, today we are going to look at a very common process known as casting. Tutaangalia casting na kisha tutamalizia hapo. I don't want us to be taking a lot of time in our online classes. I understand bundles are an issue, so let us look at casting. Now, casting, I'm sure the most common example I can give of a casting is an engine block. The process of casting is you heat a molten metal. Ukishai melt, you take that molten metal and you pour it into a cavity, shimo. Once that metal solidifies, you take it out, and that is what we call a casting. That solidified object or that solidified piece of metal. Now, that cavity is usually made by things known as molds. Mold is something that you create. Ukishaitengeneza, then you can create a cavity within it, so that when you pour your molten piece of metal into that mold, into that cavity, you can be able to break apart that mold, or you can take it apart, and what you're left with is that casting, that solidified object. Now that is the general explanation of casting. Now, casting can be of various types, but the most common one is sand casting and permanent mold casting. Now, sand casting, sana I would call it temporary. What do I mean? We don't do sand casting every day. We do sand casting kutegemea na demand. Let's say your engine imeharibika na ukaambiwa kununua engine mpya ni $1 million ama 10 million shillings. Someone can tell you, checking, my friend, naweza kutengenezea hii engine at 200,000. But how will he do that? He will not take a piece of metal kisha akaenda akachonga. No. He'll go make a cavity that resembles an engine. He'll take the piece of metal that is, let's say, steel or cast iron, and melt it. And then he will pour that molten metal into that cavity. And once that metal solidifies, he will take it out, and then he will do some machining, and you will have your engine. That is sand casting. The mold in this case is made of sand. But in permanent mold casting, that mold is no longer made of sand, but now it is made of metal. ni chuma. That mold is machined. Unapeleka chuma katika workshop, inachongwa. Labda you want to make a toy ya Superman. Unachukua chuma, unapeleka, inachongwa, inakaa Superman. You have a mold made of Superman. Now you'll be taking that mold, kisha you pour molten metal into that cavity, and you'll get your toys that resemble Superman. Sana sana we use permanent mold casting when you're making batch processes. If you're making things in batches, high production, kama unatengeneza 1000 toys per day, you will not be using sand casting, and we will see why. Now I want to introduce you to use sand casting by playing a video, so let us be attentive. Now, kuna mtu amepatana na hiyo procedure mahali? I'm sure most of us have never seen that procedure, but that is basically how most of the things are usually made. Now, I will play that video again, and I will explain as each process that they do so that we can understand what is happening. Sawa sawa. Now, what is going on is that they're making the mold, the sand mold, in which they'll create a cavity. This sand is not the usual sand ambayo unaenda unatoa kwa beach, hapana. This is a very specific type of sand. Hata ukiangalia it is black. And I'm going to give you homework. Go find out what type of sand that they use in sand casting. Now, as you can see, there are two boxes. Kuna ya juu na ya chini. They apply a white material so that that sand does not stick on that box. Wanachukua, wanajaza mchanga, alafu wanaifinyilia. The purpose of kufinyilia mchanga is so that it is tight, so that the cavity that you form in that box is rigid, isibomoke. So you have to make sure that every process unafinyilia mchanga. They then make a hole through which they are going to pour their molten metal. Now this thing, hapa, this is your pattern. This is what he wants to make from the molten metal. Now you put it in the sand, you ram the sand, then you remove it so that when you return those two boxes, sasa utabaki na cavity. Ulikuwa umeweka hiyo kitu ukaitoa, kisha ukarudisha the boxes together. What are you left with? You're left with a cavity that resembles that thing ambayo ametoa. That thing is known as a pattern. A pattern is what you want to make. These yellow things are known as cores. Labda in the thing I want to make, I want to have hollow. Nataka iwe na mashimo. And we will see that in a few. Kidogo tu. Anarudisha hizo boxes, anazirudisha vizuri so that they can form a complete cavity kuwe na shimo. They melt the piece of metal that they want to cast. Kama ni steel, kama ni cast iron, kama ni aluminium, wanaimelt. Kisha wanaimwaga katika hizi shimo ambazo alitengeneza. Now this molten metal will enter into that sand and it will fill up that cavity. Then it solidifies. Not cool, it solidifies. Once it is solid, wanavunja. They break that sand so that they can get the piece of metal that the casting. The solidified metal is known as a casting. They break away the unwanted parts. These things, hizi ndo nilikuwa nakwambia, the yellow things are the cause. Labda I want my final product iwe na shimo, a hollow part. So I will insert cause. Are we together? Tuko sawa mpaka hapo? Now let us look at some of the terms that will I can see in another class. Umeingia class wenyewe lakini ni sawa. Karibu. Now we have some terms that I want us we will encounter these terms. Ama you will encounter these terms when you do casting. Now the bottom box ambayo uliona hapo inaitwa drag. The bottom box is known as drag. And the top box is known as cope, C-O-P-E. Sawa sawa. Now, I don't know if you saw ama you were attentive, but there is a point ambapo alieka a pin inside, kisha akajaza mchanga. Once alifinyilia mchanga, akatoa hiyo pin and a hollow kukabaki na shimo. Now, that hole is known as a downscrew. This is the path that molten metal will take. That is why you'll pour your molten metal. This pouring cup, si kikombe, no. The minute he made that hole, aliingiza kidole, akapanua that hole. That is to enable the smooth flow of that molten metal into that hole. We have the mold. The mold is the sand. This is what you're using to create this cavity. We also have the cavity where you will pour your molten metal into, kisha ika solidify. In this case, this is the final product. This is what we want to make. Let's say this is a bottle. Now this core is what let's say in this cavity ama this casting nataka iwe na shimo. Hii chupa ambayo natengeneza nataka iwe na shimo. So I will insert a core. So once I pour my molten metal, itakuja, it solidifies around this core. Once it solidifies around this core, when I break my mold apart, ama when I take my mold apart, I will remove this core. Kisha what I'll remain with is a solidified piece of metal that has a hollow hole. Itakuwa na shimo. This is the purpose of cause. A riser is how tunaitumia kujua that this cavity imeshajaa the molten metal. How will you know that? This riser sana sana inakwanga imefika mpaka juu, such that when I pour my molten metal, it will fill my cavity first. Once it fills my cavity, itakuja ijaze riser. Ikishajaza riser and you see that your molten metal imefika hapa juu, then you are like, bas, imejaa. Because you cannot be able to see what is inside, what is happening inside. So you have to have a mechanism that will help you know that the molten metal has filled the cavity. And this is the purpose of a riser. A parting line. Parting line is just a partition that helps you know the difference between the top box, the cope, and the bottom box, the drag. The runner is still another passageway that will help you, that will help guide the molten metal into the cavity. Up to that point, kuna swali? Is there a question up? Okay. Now I will play a video so that we can see the procedure of sand casting. Unajua siwezi enda tu nikachukua mchanga nikaweka kwa box nikamwaga molten metal. No. There is a procedure for doing that. Let me play a video so that we can have a basic idea of how sand casting is done. So please let us be attentive.
Sand casting is the most widely used casting process in manufacturing. The advantage of using sand to manufacture products of metal is that sand is very resistant to elevated temperatures. Almost all metal casting materials can be sand cast. Sand castings can range in size from very small to extremely large. Some examples of items manufactured in modern industry by sand casting process are engine blocks, machine tool bases, cylinder heads, pump housings and valves. Now we will understand the process of sand casting in detail. First of all, on a clean floor, we will set the inverted drag box. Then we will place the pattern inside the box and pour the sand into the box. After that, sand is rammed and leveled off. The packed drag box is then turned over and cope box is placed over it. After that, second half of the pattern is placed exactly over the first half of pattern. Then the sand is filled and rammed tightly. Now two boxes are opened and pattern is removed with the help of screws. Boxes are again put back into position and clamped with the rivets to prevent upper box floating. Gates and spruces are formed to pour the metal. Now the molten metal is poured into the mold. Then it is allowed to cool down for some time. After cooling, the final cast is taken out.
Any question? Kuna swali?
No question, no.
Now let us look at advantages of sand casting. We can be able to make complex shapes in sand casting. Mfano kama engine block. It is very difficult. You cannot go into a machine shop and you ukachonga. No, you can't do that. But you can be able to sand cast an engine block by making a pattern or a cavity that resembles an engine block. And we pour a molten metal, and that molten metal will solidify and resemble that engine block. So we can be able to make complex shapes. It is also possible to cast ferrous and non-ferrous materials. There is no limitation. As long as a metal can melt, then it is very possible. Even non-metals can be casted. Ile siku ambayo utaona mchanga ina melt, mniambie hata mimi nataka kuona. So the sand is highly resistive to high temperature. So you can be able to cast metals that are of high temperatures as high as 3000 degrees Celsius. Now we have the tools. I think tumeona katika hizo video. The tools that are being used in sand casting are very cheap. They're inexpensive. They're common. Ni kitu hata ukienda kwa hardware useme unataka utapata hata na 100. They are inexpensive, they are simple. The size and weight of a product is not a limitation. I can be able to cast an engine that is over 1,000, 2,000, 3,000 kilograms. And I can cast something as tiny as a pencil. So the size of the product is not a limitation. The weight is not a limitation. What depends is how big my mold is. How well I can make my mold. Now, some disadvantages. Accuracy. Inategemea kazi yako. The craftsmanship of the casting is what will determine the accuracy. Since you're using sand, then the surface of your casting will be rough. So the finish inaitakuwa nzuri sana. You will have a rough surface. So you have to machine, you have to smooth, and you have to polish. Labor intensive, my friend. Sand casting utachoka. Your process ni ngumu sana. especially ile process ya ramming mchanga, ile ya kufinyilia mchanga. If you're lucky enough and you go to a workshop or an industry that has mechanical rammers, well and good. But that process sana is done by hand. We use rammers, hand rammers, kufinyilia hiyo mchanga. So it is a very labor intensive process. Now, some of the tools that we use in sand casting, let me go to the next slide so that we can have an image. Mfano ni shovel. I think we saw that alikuwa naitumia kuload mchanga katika zile boxes. We use that to put the sand into that box. We have trowels. We have seen this katika mjengo. Watu wa masonry na watu wa mjengo. Once they apply that cement mixture on the bricks or on the rocks ama on the wall, they use trowels kulainisha ile cement mixture. We'll do the same thing katika hiyo mchanga. Once you put the sand into the boxes, you will take the trowels and flatten. Unalainisha that surface. We have something known as a lifter. If in your, let me go back kidogo. If in your mold, mfano katika hii downspout, mchanga ukabomoka, ukaanguka in this hole, we will use a lifter. Unachukua lifter, unatengeneza hiyo shimo vizuri. You remove that sand ambayo imebomoka ikaingia katika ile shimo. So a lifter is usually used to fix those broken holes, ama ile mchanga ambayo imeingia katika mashimo. We have a strike off bar. Let me go back again. Once I have poured my sand into these boxes and I have excess sand on top of those boxes, I will use a strike off bar to nitaipitisha juu ya box. I will pass it over the box and any excess sand ama unwanted sand will be removed. That is what we use a strike off bar for. We have a riddle. Riddle ni kichungi tu. Especially when it comes to the sand around the pattern. We want that sand to be fine, very fine. Hatutaki mabonde katika mabonde ya mchanga around the pattern. So we put the sand into that riddle, kisha tunachunga. So we'll have fine sand falling on top of the pattern. Then we can then add sand using the shovel and then tunaifinyilia. So riddle ni kichungi. Vent wire. Now this is a very important thing that I didn't show in the video. Once you're done making your mold, na ushamaliza and you want to pour your molten metal, a very important process is venting. Utachukua vent wire kisha unatoboa mashimo katika ile mold ya sand. The reason is the hot metal ama the molten metal contains gases, hot gases. So once you pour that hot gas into that cavity, these hot gases will be looking for ways to escape. And if you haven't provided vents ama njia hiyo hot gases to escape, then those hot gases will expand within your mold na itaivunja. It will break it apart. I had given an assignment katika ile Google Classroom and I don't know if everyone has been able to see it. Defects in casting. I want you to go read using diagrams, andika kitu kidogo. One of those defects is if you don't allow for those hot gases to escape, your casting itavunjika. Your mold will break apart. Now, rammers are what you use kufinyilia ule mchanga. If you're in an industry that is, ama in a plant, ama in a workshop that has mechanical rammers, well and good, you'll just put your box and itafinyiliwa na hiyo machine. But if you're doing it by hand, utatumia these hand rammers. Zinakaa ile kisiagi ya mahindi, ile ya mkono. Unafinya, unabongelea mchanga kwa hiyo box mpaka iwe tight vizuri. A sprue cutter. Now we use this. Let me go back kidogo. We use a sprue cutter to make this hole. This passage ambayo you'll pour your molten metal into. We use a sprue cutter. So ideally what we do is we put this sprue cutter katika box. Kisha tunaeka mchanga juu. We fill the box with sand and we ram it to make it tight. Once we are satisfied, we will remove that sprue pin or sprue cutter. And what we are left with is a hole, ama passage for that, mahali ambapo the molten metal will pass through. Are we together?
Yes.
Yeah, together.
If you are together, unmute and say, I am here. I am present.
Present.
Thank you. Now, what we've just talked about is sand casting. The mold was made of sand. Now, the opposite, the other type of casting is permanent mold casting. And in this case, the mold is no longer made of sand, it is made of metal. Ni permanent. You won't have to break it at ndio ili upate the casting. No, it is made of metal. And the mold is usually made of steel, cast, aluminium, depending on the metal that you're casting. What you do is you take this piece of metal, unaipeleka workshop, ikachongwa, so that it is the cavity, ama the pattern of what you want to make, it is made within that mold. Imechongwa katika hiyo mold, so that when you combine those two molds, what you are left with, ama whatever is formed inside, is the cavity. In this case, hautakuwa unatengeneza pattern, hapana. The pattern is made inside the mold. Is made inside the mold. Now, the steps that we take in permanent mold casting is you have those two molds. One is usually fixed in place and another one is movable. So these molds are preheated and are usually zinakuwa sprayed na coating. This is ni kama lubricant. So that molten metal, once it is poured into that cavity, it flows easily. Inaingia polepole ama inaingia vizuri sana. So we preheat it and we apply a coating of lubricant. Ukishamaliza unafunga. You close your mold. The reason we close our mold is so that we can form a cavity. Because our pattern is usually imprinted. Sana sana inakuanga imechongwa katika hizo mold. Tukifunga, that is when the cavity will be formed. Once that cavity is formed, we pour molten metal into that cavity. Once you pour that molten metal into that cavity, it will solidify. Look, I want you to note, I'm not saying it will cool. Haitapoa mpaka ikapoa kabisa. No, it solidifies. The minute it solidifies, we open our mold and we remove our casting. Are we together?
Yes.
Now, the reason why I'm not saying cooling, especially katika permanent casting, I think we can read this part, is that if I let it cool beyond a certain point, this is a permanent casting, the shape will not change, the dimensions will not change. Kwa hivyo itafika mahali during the cooling process ama the solidification process, that permanent casting will not accommodate that cooling. Itafika kwa sababu haisongi, the dimensions are not changing, haita accommodate the cooling process. So what will happen is cracks will form. I gave you an assignment, enda uangalie defects in casting, find out what causes them and how they look like. Nipatie tu jina kidogo na nimeona kuna mtu asha submit. Now this is a diagrammatic representation of that process of permanent mold casting. We have a permanently fixed mold and we have a movable mold. Now this is what I mean when I say that the pattern has been imechongwa katika that mold. Hatutakuwa tunaweka pattern katika mold. No, the pattern is part of the mold. We preheat that mold and we spray some form of lubricant. Once we are done, we close them. Tukifunika, we form the cavity. Now, if I want to make a workpiece, my final product, nataka iwe na hollow part, I will insert a core, so that when I pour my molten metal into that cavity, it will solidify around that core. And once I open the cavity, the mold, and nikitoa that core, what I'm left with is a casting that has a hollow part. Ukishafunga, you pour your molten metal into that cavity. Once it solidifies, you remove the removable mold, and what you're left with, in this case, this is our final product. This is our casting. Sawa. Now, there are certain advantages of using permanent mold casting. The biggest one is surface finishing. You can imagine the surface of a piece of metal and the surface of sand. The surface ya chuma will be smoother, will be finer as compared na ile ya mchanga. So the surface ya chuma, the casting that will be produced will be smoother than that produced using sand casting. Now, dimensional control, the accuracy of your finished product will be better. Reason being is that your sand casting, your permanent mold is permanent. It doesn't change. Dimension haibadiliki. If my final product will be 10 centimeters by 10 centimeters by 10 centimeters, then tolerance itakuwa very, very minimum, maybe plus or minus 0.05. In sand casting, my dimensional accuracy is dependent on the work I do. If I do my work very well, if my craftsmanship ni nzuri sana, then I will have a good final product. Nikifanya kazi mzaha alafu for example, si kama sitafinyilia mchanga vizuri, then my workpiece ama my casting will come out horribly. The reason now, since we have good dimensional control, then the internal structure of that casting will be fine. If I'm making a workpiece, my casting is 10 cent. My mold is 10 centimeters by 10 centimeters. I pour molten metal, and what comes out is 10 centimeters by 10 centimeters. The internal structure will be better as compared to a sand casting, ambayo it is dependent on the work of that person doing the process. For that reason also, casting ambazo na produce are stronger. The internal structure, the internal bonds are stronger. Sawa. Disadvantage, DEP. The biggest disadvantage is I cannot cast a metal which has a higher melting point than my mold. Remember, permanent molds are made of metal. If let's say my mold is made of steel, and let's say that the melting point of steel is 1,000 degrees Celsius, I cannot cast a metal whose melting point is above 1,000. Sawa. If I pour a metal whose melting point is 3,000, itaharibu my permanent mold. Itaichoma, itaiunguza. It will even melt it. So it is only limited to metals with a lower melting point. The making of those molds is also expensive. Hiyo kuchonga hiyo pattern katika hiyo mold ni very expensive. That's why it is usually limited to very tiny products. Utapata inatengeneza toys. It is in very, very tiny pieces, very simple parts. Because it is very expensive to produce those molds. Now, this is it's a simple diagram showing different types of defects that can be found in castings. What I want you to do in your assignment is I want you to go find easy defects. Come up, chora diagram. Explain how they are formed. Are we together? Tuko sawa?
Yeah.
Kama tuko pamoja, unmute and say I'm here. I'm present.
I'm here.
Thank you.
Yeah.
Yeah.
Now we're almost done. Tuko karibu kumaliza. Now, I think katika ile video ya kwanza ya casting, ile sand casting, once they were done with that process and they removed the mold, they removed the solidified piece of metal, walikuwa wanavunja ile mold, wanachukua nyundo, wanagonga, wanatoa mchanga. So once you're done with your casting process, you have to make sure that the final product is what you want it to be. Si ati ukishatoa ile casting umemaliza kazi, no. You have to machine it, you have to clean it, you have to polish it so that it can have that final desired product. Now we can classify the cleaning into very simple categories, kama rough cleaning. Let me go back kidogo. And I want to use this diagram to explain. Now, I've poured my molten metal into this, through this cavity. Ikaja ikajaza hii cavity. What I want, ama my final product, is this bottle. Nataka hii ndio nataka. But since nilimwaga molten metal ikajaza huku, saa zingine if I had made vents, zikajaa pia na molten metal. Once those parts solidify, I will have this, my final product, but I will also have this, and I do not want this. So what I need to do is remove them. And how can I remove them? Kuna ile rough cleaning. Naweza chukua ile cast nikaangusha, ikavunjika, those unwanted parts ikavunjika. I can take a nyundo nikagonga nikatoa those parts. Surface cleaning. The materials that usually are here ama zina stick on the surface of those castings. The sand, mfano in sand casting, in a stick because of the hot temperatures. So I have to remove that sand. I can use a wire brush. I can use grinders. Trimming. There are very small pieces of metal that are unwanted in that casting. So I remove them. Another, to me, a chisel. I can use a file to remove those unwanted parts. Finishing. Once I'm done with all those processes, then I can do the finishing and decorative processes we had talked about in our last class. Electroplating, polishing, buffing. Depending on the purpose of your casting, then I can apply those finishing processes. Now, let me play a small video that will show someone cleaning his casting.
YouTube, this morning we're going to be cleaning up the casting that we made last night. So I'm going to start by cutting the sprue off.
Now what he's removing is that place ambapo ulimwaga the molten metal. That part will also have you can remove this using a hacksaw.
Okay, so yeah, I ground those off with the grinder. That was a lot easier. Alright, so I'm going to reseat this guy again. Check it for true. Alright. There's the start.
Now let me mention something. For those people who have never seen a lathe machine, do you have LATHE, lathe machine? I was explaining this especially katika ile topic ya workshop safety, and I tell you not to have loose clothing in the workshop, kwa sababu ukiwa na loose clothing inaweza shikwa katika hii rotating head ikakuvuta ndani. So use it for machining processes, cutting, drilling, facing, turning. We will see this when you go to workshop.
Alright, YouTube, here's the pattern. And here's the casting cleaned up with the screws cut off.
This is his pattern. This is what he will place in the sand mold. Akishaweka hii anaitoa. What is left in the sand mold is a cavity. Akishamwaga the molten metal and it solidifies, this is what he gets. This is what he wanted to make from the molten metal. So as you can see, kama this surface finishing in sand mold is poor from sand casting. So that is a very basic video of cleaning of sand casting. You can do that in many ways. Are we together? Now, the last thing we will talk about today in inspection of castings. We have to ensure the castings that we make are of standard. And how do we do that? There are very many ways of doing that, but the most common are non-destructive methods and destructive methods. As the name implies, in non-destructive, hauharibu that casting. What we do is let me give a very simple example. Unapeleka casting ifanywe X-ray, radiographic inspection. Once you do an X-ray on that casting, then we can be able to see the internal structure of that casting. If there are any internal cracks present, we will be able to see them. Another one, fluorescent dye penetration. What you do is you take a dye, a colored liquid, you apply it on the surface of a casting, and then you wipe it off. If there are cracks, there are holes in that casting, then that dye, that colored liquid will remain in those cracks, in those holes. Then you will know that there are cracks or there are holes. And there are so many. You can use magnetism to determine whether that casting has cracks. The other method is destructive. As the name implies, you will take a casting and naipeleka lab, and it will be tested. Itachukuliwa ikavutwa, and we will see at what force, at what stress it will break. It will be broken. It will be taken through many tests to test the hardness, the durability of that casting. Let's say if I'm casting a suspension ya gari, I have to know that casting will be able to withstand those forces. And how I do that is by taking that casting into a lab, and I take it through destructive inspection methods. Are we together?
Yes.
Now, for today tutaachia hapo.